revised nature of roots. If b square minus 4ac is greater than 0, distinct real roots. If the discriminant b square minus 4ac is equal to 0, equal real roots. If the discriminant b square minus 4ac is less than 0, no real roots or imaginary roots or roots does not exist. Exercise 4.4, question number 1. Find the nature of the roots of the following quadratic equations. If the real roots exist, find them. 2x square minus 3x plus 5 is equal to 0. For finding nature of roots, we have to find the discriminant b square minus 4ac. b square minus 4ac is equal to b is minus 3 whole square minus 4 into a is 2 into c 5. 9 minus 4 2s are 8, 8 5s are 40. 9 minus 40 minus 31, which is less than 0. So, no real roots. Question number 2. 3x square minus 4 root 3x plus 4 is equal to 0. Here, b square minus 4ac is equal to b is minus 4 root 3 whole square minus 4 into 3 into 4. Minus 4 root 3 whole square is nothing but 16 into 3 minus 48. This is 48 minus 48, 0. Here, b square minus 4ac is equal to 0. So, equal real roots. So, in this case, without using this quadratic formula also, we can find roots. So, the roots are minus b by 2a and minus b by 2a. In this case, b is minus 4 root 3. So, minus of minus 4 root 3 by 2 into a is 3. And 4 root 3 by 6. So, here 4 root 3 by 6 and 4 root 3 by. If you cancel 2 table and root 3 in 3, root 3 times it will cancel. So, therefore, the roots are 2 by root 3 and 2 by root 3. This you can use only when the roots are equal. So, third one, 2x square minus 6x plus 3 is equal to 0. Here, the discriminant b square minus 4ac is equal to minus 6 whole square minus 4 into 2 into 3. 36 minus 24. That is 12, which is greater than 0. So, distinct real roots. So, by using quadratic formula, x is equal to minus b plus or minus square root of b square minus 4ac by 2a, that is equal to minus of minus 6 plus or minus square root of b square minus 4ac is 12. Discriminant is 12 by 2 into 2. So 6 plus or minus square root of 12 by 4. So 6 plus root 12 by 4. 6 minus root 12 by 4. So this is 6 plus root 12, we can write it as 2 root 3 by 4 and 6 minus 2 root 3 by 4. Take 2 as common factor, 3 plus root 3 by 4. And if you take 2 as common factor, 3 minus root 3 by 4. This 2 in 4, 2 times you can cancel. So 3 plus root 3 by 2 3 minus root 3 by 2. Therefore, the roots are 3 plus root 3 by 2, 3 minus root 3 by 2. So question number 2, find the values of k for each of the following quadratic equations so that they have two equal roots. So for equal roots, discriminant should be 0. So the discriminant b square minus 4ac is equal to 0. Here b is k. So k square minus 4 into a is 2, c is 3 is equal to 0. So k square minus 24 is equal to 0. K square is equal to 24. K is equal to square root of 24. So K is equal to root 4 into 6, that is plus or minus 2 root 6. Therefore, K is equal to plus or minus 2 root 6. The quadratic equation is kx into x minus 2 plus 6 is equal to 0. Open brackets. Kx square minus 2kx plus 6 is equal to 0. Here a coefficient of x square k, b is coefficient of x minus 2k and c is 6. Now for equal roots the condition is b square minus 4ac is equal to 0. So minus 2k whole square minus 4 into k into 6 is equal to 0. So 4k square minus 24k is equal to 0. So 4k square is equal to 24k. So 4k square by k is equal to 24. 4k is equal to 24. K is equal to 24 by 4, that is 6.